Hello and welcome everyone to a demonstration of our senior project. This project was created by Josiah Buxton and Sajid Amir, both computer engineering majors from the class of 2015. So this is our application GUI, and we decided to use Java to create our senior project. And we're going to try to simulate an artificial neural network through Java. And these three buttons right here in the top corner show the three functionalities of the program. I'm going to demonstrate the OR functionality first. So I'm going to click the OR button, and then I'm going to click the train button. As I mentioned earlier, we need to train the artificial neural network for it to be able to predict an outcome. So clicking the train button brings up this graph, as you can see. This graph, what this shows are actually four possible inputs. And as you can see, the pinkish line, it's kind of hard to see, but the pink one is a 0, 0. The red one is a 0, 1. The yellow one is a 1, 0. And the black line is a 1, 1. And we're at 1,000 epoch by pressing the train button once. The program actually trains the artificial neural network 1,000 times. The x-axis right here shows the number of epochs. And we can actually see the total average error, the global error at the moment, by clicking the calculate RMS button. I'm going to click that, and as you can see, the error is almost 0.39. So let's just remember that our error right now is a 0.4. And clicking the weight matrix shows all the weights associated inside the neural network. So all the input nodes, the hidden nodes, you can see the weights associated right here. And from the hidden nodes to the output nodes, you can see the weights associated right here. The weights do change with every epoch. So let's train the network a couple of thousand more times, actually a lot more times. So we're going to train the network to 10,000 epochs by clicking the train button multiple times. As you guys can see, when the input is a 0 and a 0, the network is predicting that the predicted outcome should be a 0. It's going down. And when the input is a 0, 1, a 1, 0, and a 1, 1, the predicted output should go up, and it is going up. These two are kind of slightly going down, but I believe it should go up. Let's train it a few more times. As you guys can see, the output right here is almost at a 1, and the output over here is almost at a 0. So now let's actually put in some values. Actually, before I do that, I want to show you guys that the error has gone down. As you guys can see, the error right now is only a 0.05. It was a 0.4, and from 0.4 it's a 0.05, and the weights have changed accordingly to be able to predict the correct outcome. And if you press the show threshold matrix, it shows that all the thresholds associated with our project, and the thresholds are 0.5 throughout the whole project. Let's put in some actual values. We're going to put in a 0 and a 0, and it's still ORing them together. So the expected output should be a 0, while the output from our prediction of the network should be a 0 as well. So let's click the output button. As you can see, our network just successfully predicted that when a 0 is ORed with a 0, the answer should be a 0. And because that's the expected, you can just see it's correct. Okay, so let's put in a different value. If we OR a 0 and a 1, the expected output, of course, should be a 1. So let's see what our network predicts. And our network predicts that the output should be a 1. So that was the OR functionality. I could give you guys another demonstration. If we OR a 1 and a 1, as you can see, clicking the output button, the output is still a 1, and with the expected output to be 1. The AND and the XOR buttons function very similarly, but to achieve that, as you can see, clicking that changes the GUI to an AND neural network, and we have to train the neural network again, of course, and by pressing the train button, and this brings up a graph very similar to the previous one. It's at 1,000 epochs at the moment, and the inputs are again 0, 0, 0, 1, 1, 0, and a 1, 1, the green one being 1, 1. So let's train it some more. As you guys can see, finally the values are starting to get where they're supposed to be after 11,000 epochs. And training it some more will get the values accordingly to where it needs to be. And the XRF button works very similarly, and we'd have to train the whole thing and it would achieve very similar results. Thank you everyone for your time. I